Hi and welcome to this Grasshopper plugin tutorial. We're going to firstly start in Revit, and this is just to make sure that you're exporting your VREPs right. So firstly you want to be in 3D view, then you want to make sure that the floor and walls are not overlapping. This is just so the plugin works. Then you're going to click on File, Export, choose the CAD format, the DWG file, and inside of here you want to modify export setups. Click on solids and make sure you are turned to axis solid and not the poly mesh. This is to make sure that it's a BREP and not a mesh. Then you can just click on OK, click on next, and then save it. I've already gone ahead and done that, so I'm just going to click on cancel. So inside of Rhino, you want to first and foremost make sure that you have Grasshopper open. Gonna click on Grasshopper and then click on Grasshopper. And then you can just open from File, click on Open, and open the Descale BREPs file. So then we can import the file from Revit, and you can see here, here's my test house, the demo house. Just gonna click on open, and you want to keep the settings as is, as we're gonna modify and descale it in Grasshopper. And you can just click on OK. And you might not see it, but it's quite large because you cannot see the grid anymore. And also you can see in the bottom here that the scales are much larger. So for us to then be able to descale it, we're just going to use the geometry pipeline inside of here, and then it just descales it, so you get much smaller BREPs. So we can zoom to it. If we just hide that one, then you can see that the BREPs are much smaller and easier to work with. Also, it's inside of the grid. So then we can use find the plugin, and it's inside of NTNU, and then the master main. Here we have the stud work with openings for BREP walls, and you can just go ahead and connect that BREP walls for input and BREP floors for input inside of these two, and then you can just give it a center distance. I have chosen 0.6 as the most common one, and what it's doing now, it's trying to find the height of the walls and also separating the walls according to their location, so like min x, max x, min y, and max y. And then when it's done, it has created this stud work. Inside of here you can just hold your mouse over it, and then you can get the information on how the tree is. But to simply view the tree, you can also use Parametric, and it's gonna tell you how many branches there are and how many elements there are in each branch. You can also click on it and do the draw tree to see the tree instead of branches. Now if you want to go into a specific branch, you can just search for the tree branch, and then it's going to ask about the path. So let's say we want to see this wall and its studs in that wall. Then we're gonna use now this is the minimum X value, so that means we need 0. So just using the panel, you can just write the path you wanna see. So if we just hide this one, you can now see all of the studs with the joints in the min X value. So that's for viewing the gem. So this all of the branches with the first number 0 are the branches for the wall. So that means every beam and stud in the wall, while all branches with the first number as 1 are the branches that are for the floor and their beams in the floor. The second number for the walls, so just looking at the first ones here, tells you which wall direction it is. So the 0 is, like it's written here, it's the min x value. The 1 is the max x value. The 2 is the min y value. And the 3 is the max y value. And the last number on that branch is telling you whenever it's a column or if it's a beam. So 0 is a column, while 1 is a beam. And for the floors, this will just, the first number will tell you that it's the floors, while the second number will tell you which floor it is on. So 0 means that it's the first floor for this one. I hope this tutorial was useful and that you liked it. Thank you.